Hello and welcome to another one of these ADD videos. Today we're going to be discussing inference about two populations, specifically two populations with independent samples, okay, coming from two distinct independent populations. So if the populations have equal variances, then we use this method here. Now, the populations in general have unknown variances. Okay, it's rare that you know the entire population's variance. So what's going to happen is you can have a choice between either the equal variances or the unequal variances. Okay, so if the variances are equal, this is your test statistics formula right here, and we are going to have what's called a pool variance because they're equal. It's basically the degrees of freedom times the variances over the total degrees of freedom. So degrees of freedom of 1 times the variance of 1 over the total degrees of freedom. And that's again the total degrees of freedom, how you came up with that formula. The confidence interval estimator would change a little bit in this scenario. It's still based off the sample means, but it's the difference of their means in this case. Since the population standard deviation is unknown, or variance is known, you have to use a t-score there, and a pooled variance here. And this is going to be method 1 if the variances are equal. But if they're unequal, still with unknown, then the test statistic becomes this, which is not too bad, right? This denominator simplified a little bit. But look at this wonderful degrees of freedom. All it is variance over sample size added together, and then variance over sample size squared over the degrees of freedom added together. And this is method 2. So which one do we use? Do we use method 1? Method 2. Method 1? Or method 2? Is this making you dizzy? Well, the question then becomes an F-test scenario in which we have to determine if the variance indeed are equal or are the variances not equal. So we do a ratio of the sample variances with the degrees of freedom of the numerator, V1, and degrees of the denominator, freedom of V2. And basically it's a two-tailed test, and if we land in the middle, right here, yellow region I just highlighted, then the variances will be equal. Okay, we use method 1. Basically, if we're not greater than a certain value or less than a certain value that we get from our F table. Okay, so if you forgot what an F table looks like, nice enough to have one handy dandy right here. It pulls up. So here's your F table. This right here is your denominator degrees of freedom for sample 2, and the numerator sample 1. In our case we have, actually we haven't done the sample problem yet, so we'll get to that when we do the sample problem. But your textbook should have one of these tables in the back of your book if you don't see it. Go on the internet and you can find one, or on my website. So here we have the alternative. If they're not equal, let's say our F ratio of samples landed either in either rejection region, either it came somewhere over here or somewhere in this area, then we would use the second method, in which this is your test statistic, that's your degrees of freedom. Okay, so this is again for two independent populations with two independent samples, and we need to know if the samples or variances are equal or not equal. Use the F test first, these two possible hypotheses, and then you can start talking about your individual t-scores and test statistics and things like that, setting up your null hypotheses for the two samples. Okay, so I hope that's clarified any information that you, or any discrepancies that you might have. The main thing here is to practice, and watch the example videos as well. Thank you and have a nice day.